Hi everyone, we are in our last unit of Acellus, and like I said, I was going to give you guys a video to kind of help you through these first couple of topics. Neither one of them are too terribly complicated, but they really aren't related. It's kind of a hodgepodge of topics in this last unit. So I'm going to go through the two topics because I won't be here for the first couple days this week. Like I said, we don't have class on Tuesday, but this is going to supplement that. So the first thing I want to talk about is the binomial theorem. And the binomial theorem actually allows us to expand a binomial raised to a power. So think about this for a second. If I had x plus y squared, that would just be x plus y times x plus y, right? And if I FOILed that out, I would get x squared plus 2xy plus y squared, right? And x plus y cubed would be x plus y times x plus y times x plus y. And if you could also think of that as x plus y squared times x plus y, right? So I could take the x squared plus 2xy plus y squared and multiply it by x plus y and expand that out. And when I expand that, I would get x cubed plus 3x squared y plus 3xy squared plus y cubed, right? And I can keep doing that to multiple powers and keep expanding them out and doing it the long way. But there's also a shorter way to do it. And what I want you to recognize are my coefficients that are happening here. So if I highlighted them, I've got, that would be 1, here would be 2, here would be 1, here would be 1, here would be 3, here would be 3, here would be 1. And I could keep going. And if I actually went back and filled in x plus y to the first, that would just give me x plus y, right? And that would have coefficients of 1 and 1. And if I went back and had, and I kind of ran out of room here, but if I went back and move this up. If I went back and did x plus y to the 0 power, x plus y to the 0 power, that would just be 1, right? Because anything to the 0 power is 1. So if you look at your coefficients, and I'll put them in red so you can see I've got 1, and then this would be 1, this would be 1, this is 1, 2, and 1, this is 1, 3, 3, 1. And if I were to kind of just pull out those coefficients and write them down line by line, I'd have 1, then I have 1, 1, then I have 1, 2, 1, then I have 1, 3, 3, 1. Those are the 4 lines of coefficients that I have up there. And now, maybe with it written out like this, you can see a pattern. If you notice on the that forms a triangle, and on the outsides of that triangle, I have 1s. And then every number in here is the sum of the 2 numbers above it. So if I add 1 and 1, I get that 2. If I add 1 and 2, I get 3. If I add 2 and 1, I get 3. Right, so I could write out my next line of coefficients. So I would have 1, 4, because 1 and 3 is 4. 3 and 3 is 6, 3 and 1 is 4, and then I would have 1. And I can keep going. 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and then 1 on the end. That's called Pascal's triangle. Pascal's triangle. And basically what this says is if I'm raising any binomial to some power, I can get my coefficients, or at least part of my coefficients, from this triangle, right? So if you think of this first one as something to the 0 power. This next line is something to the first power. This next line here is something to the second power. And if you notice, there's also another pattern going on here. The number of coefficients you have is one more than the exponent, right? This is first power, but I have 2 coefficients. Up here, this is to the second power. I have 1, 2, 3 coefficients. Here's the third power. I have 1, 2, 3, 4 coefficients, which means that I have 4 terms. So whatever power you're raising it to, you also know how many terms you have when you expand it out. You're always going to have one more term than whatever that exponent is. You can say, well, that's all well and good, but I still don't know what to do with that. Okay, well, let's look at some other patterns. And the reason that I'm doing it this way is so that you have a shortcut method of expanding out your binomial. You don't have to go through the tedious process of multiplying binomial by binomial by binomial and doing distribution over and over again. This way is much easier and it's very systematic. Now, if we take a look at what's happening here, and I think it's most evident if you go down to this third one. If you notice, the first term in my binomial is x. So I start at x to the third. Remember, 3 is the exponent that I'm using here. So I have x to the third, and then in the very next term, it's x squared, and then in the very next term, it's x, and then in the last term, it would be x to the 0, which is just 1, so we don't have to write it. So if you notice, that first term in that binomial is starting at that highest exponent and decreasing by 1 as you go from term to term. The second part of the binomial is starting at the 0 power. Notice that there's no y term in this first part of the expansion because y to the 0 is just 1. But then you have y to the first, then you have y squared, then you have y to the third. Okay, so whatever that first term is, it's going to start at that highest power and go down by 1 each time. Whatever that second term is, it's going to start at the 0 power and go up by 1 each time. So let me show you how this would work. If I had to expand the following. If I was expanding x plus y to the 5th, okay, the first thing I'm going to say is, okay, if it's the exponent is 5, I have one more term than that. That means I have 6 terms. So what I like to do is draw that out. 1, 2, 3, 4, 5, 6. I think drawing it out like this just makes it easier to kind of follow along. Okay, now to Pascal's triangle. If I recreate Pascal's triangle, and once you have this once, you don't have to keep recreating it. It is very easy to recreate. Remember, because I have the 5th power, I need 6 terms. So I have to go down to the line that has 6 terms. 1, 2, 3, 4, 5, 6. Okay, so those are the start of my coefficients. So I have 1, 5, 10, 10, 5, and 1. Okay, that takes care of that part of it. Now, I'm going to go to my binomial. Whatever the first term is, in this case it's x, I'm starting at the 5th power, and I'm going to reduce it by 1 as I go from one term to the next. So here, it would be x to the 5th. Here, it would be x to the 4th. Here, it would be x to the 3rd. Here, it would be x squared. Here, it would be x. Here, it would be x to the 0, which is just 1, so I'm not even going to write it there. Okay, the next part, I'm going to look at y. And y is going to start at the 0 power, so I'm not even going to write it in the first term. But then here it would be y to the 1st. Then here it would be y to the 2nd. Here it would be y to the 3rd. Here it would be y to the 4th. And here it would be y to the 5th. So notice that my exponents, within each term always add up to 5. So I have 5 here, that's just 5. 4 and 1 adds to 5. 3 and 2 adds to 5. 2 and 3 adds to 5. 4 and 1 adds to 5, and then I just have 5. That's always going to be the case. Those are the terms of my binomial expansion. So if I were to just write it out, I would just have x to the 5th plus 5x to the 4th y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the 4th plus y to the 5th. That would be the binomial expansion. Now, because this has a plus in it, all of the terms here are plus. Let's change it up in our next example. Let's say this time I have 2x minus 3y to the 4th. Okay, so I've changed it up a little bit. So my exponent is 4, which means I have 5 terms. 1, 2, 3, 4, 5. I'm going to the row of Pascal's triangle that has 5 terms. 1, 4, 6, 4, 1. So I'm going to do 1, 4, 6, 4, 1. Now notice what's going to happen here. My first term is 2x, so I have to take 2x and raise it to the 4th power. So I'm going to put that in parentheses. I have 2x to the 4th. Then I have 2x to the 3rd. And then I have 2x squared, 2x to the 1st, and 2x to the 0 would just be 1, so I don't need to write it in that last part. Okay, and then I'm going to do the same thing. I'm just going to do it in reverse for the next term, the second term. So this is negative 3y. So this would be negative 3y to the 0 power, which would just be 1, so I can skip that first term. Then it's negative 3y to the 1st. Then it's a negative 3y to the 2nd. Negative 3y to the 3rd. And negative 3y to the 4th. So in this case, because I don't have just x and y in my binomial expansion, because I have that 2 and that 3, that's going to change my coefficients. But I still have to use those coefficients from Pascal's triangle. I'm just going to end up multiplying them by my other numbers that I have there. Okay, so 2x to the 4th. So 2 to the 4th would be 16. 16 times 1 is 16. So that is going to be 16 x to the 4th. Now I have 2x to the 3rd. So 2x to the 3rd, that would give me 8x cubed times 4 times negative 3y. So 8 times 4 is 32. 32 times negative 3 would be negative 96. So I have negative 96 x cubed y. So you have to follow order of operations. You have to raise them to the power and then multiply by that 4. Okay, so here I have 4x squared times that 6 times 9y squared. So 4 times 6 is 36. 36 times 6 is, I think it's 216. Let's double check. 36 times 6 gives me 216. Okay, so that would be plus 216 x squared y squared. So here I have 4 times 2x times negative 27y cubed. So I've got negative 27 times 8, and that's negative 216 xy cubed. And then 3 to the 4th is just going to be 81, and that's going to be positive 81y to the 4th. So notice I'm just alternating my signs there when there's a negative, but notice how I went through and did that. So hopefully that will help you with those problems, and I'll do the other part in the next video. Thanks, guys.